Hello everyone, I hope this video finds you doing well. In terms of the course, the fun stuff we're going to leave behind at this point, meaning the technical symbolic material. We are now going to explore what is called informal logic. That is, we are going to move away from using symbols and translation, etc., and we're going to start analyzing and evaluating ordinary language and mistakes in arguments called fallacies, basically errors or mistakes in reasoning. We will also explore tricky uses of language and tricky moves made in reasoning that are not logical but are rather psychological, and Manji refers to those as rhetorical pitfalls. So I'm thinking most of you are going to find the rest of this course, the last few weeks we are together, quite interesting and less technical and more accessible, more easy to understand. Anyway, I hope that is the case. In terms of this week's topic, it is about poverty in America. I don't know about you, but throughout my life I've heard quite a few fallacies, in particular inductive fallacies, about poverty in America and also about homelessness in America, and both are linked, as you can imagine. If you want to explore the topic in terms of research, some good sources that I have found online are povertyinamerica.mit.edu. I tend to prefer going right to university websites, .edu sites. They tend to be more accurate and reliable. And feedingamerica.org is also a good site. Many sites draw from the U.S. government census, so you might want to go right to the source and check out census.gov if you want to explore poverty and homelessness in America and use that to create fallacies with. Also, I just wanted to share with you that the various sites that I've been exploring hold that out of the many people who are homeless in the United States, 40 to 60,000, that is the range of estimates I have observed. 40 to 60,000 are homeless veterans, which is, I think, a sad and shocking statistic. And 1.5 million children are claimed to be homeless in America. What's interesting also in terms of this topic is to explore not only fallacies, but that part of induction called statistical reasoning, and to ask questions like, how are these numbers generated? When people count homelessness in America, for example, does being homeless for a day get counted in that number on the U.S. Census, or is it a week? Is it a month? To think about such questions is also an interesting part of logic. Okay, so the final thing I'd like to address right now is actually chapter 18, something we just covered. It seems like some of you are still having trouble with truth tables, indirect truth tables. So I thought I'd just cover a couple of examples with you. If you don't want to cover this, you can shut down this video. I just wanted to say hello and show my face and connect with you all. But if you want to stay for indirect truth tables, here we go. Let me show you one argument. I hope I wrote this down right. Yes, that looks correct. So here's an argument. The first thing we want to do is isolate premises from the conclusion and make them clear and distinct. So we use something like double slash for the conclusion, and then the premises can be separated simply by a line. Some of you used a matrix. I have two. We've used different symbols. Some of you use triple dot over here instead of double slash. It doesn't matter what symbol you use. This is standard technique, but you can use different symbols. As long as things are made clear and somebody can identify the conclusion as contrasted with the premises, we're going to be okay. All right, so here we go. Here's the first thing you need to do. Start with the initial working assumption that the argument is invalid. If the argument accepts that assumption, then it is invalid. However, if the argument resists that initial assumption of invalidity, that means the opposite is the case. In other words, that means the argument is valid. So let's see what we get. Let's start with our initial working assumption. I'm going to turn here and fill in the values for the table to identify our initial working assumption. So I'm going to put a T under the horseshoe, a T under the tilde next to the Q, and an F under the tilde in our conclusion. Sorry about that. So here we go. our initial working assumption is this, that all premises are true and the conclusion is false. If the argument accepts this, again, it's clearly invalid, so we will say the argument is invalid. If the argument resists this, we will say the argument will never let it occur that all true premises can exist with a false conclusion in this form. So let's see where we go from here. Let's put a T under the P and F under the Q, and then we can work backwards and fill in any other blank columns. So I'm going to put a false under the Q, a true under the P. All right, so that's our next move. Now you note that we have the values for P and Q. So let me fill those in. All right, notice what has happened. We've got a T and an F here. For the horseshoe operator, TF is F. So the argument is resisting this assumption. So I'm going to write /F to show that we have a contradiction here. TF actually gives you F. So what the argument is doing, if you want to think of it this way metaphorically, it is fighting back. It is resisting the initial working assumption of invalidity, meaning that the argument will never let it happen that true premises result in a false output. Not this argument form. It will resist the assumption of invalidity, meaning it is valid. It's a great argument. Never will this argument allow that you can have all true premises in a false conclusion. Okay, I hope that helps. Let's do one more. Consider this argument here. Again, I'm keeping these simple so that we can get through this without me turning and spending too much time away from the camera. So I'm going to plug in our initial working assumption. Can you guess what it is? What are we going to do? Think about that for a second. All right. What we're going to do is assume all true premises and a false conclusion. Let me write that down here. All true premises and a false conclusion. Let me see if I got that right. Yes. So that's our initial working assumption. Note that we have the value for T and the value for E, and the value for P. So let's go ahead and work backwards and plug those in. Okay. So, since this was T, all E's are going to be T, including this E. And since P was F, all P's have to be F. Note what has happened here. FT is T for the horseshoe. In other words, the argument has not resisted our initial working assumption. It has accepted it. Our initial working assumption is that the argument is invalid. Since the argument has embraced, has accepted that initial working assumption, we can conclude that the argument is faulty. It is, after all, invalid. And there's our proof right here, the indirect truth table. I hope you've enjoyed that method. It's the one I use on paper and in my mind when I'm listening to somebody's argument. I try to figure out if it's somehow possible that all true premises can result in a false conclusion, or if the argument resists that. I think you get that basic methodology. It takes a lot of practice to get to the point where you can work things out like that to some extent in your mind, although even I have difficulties with this still, especially with complex arguments. It is a very useful, very powerful, very efficient methodology for analyzing and evaluating deductive arguments. Okay, I think that's enough for now. I hope you enjoy the rest of the course. I hope it really helps you refine and develop your ability to reason critically. Take care now. Until next time.